Okay, today we're going to look more at curve sketching, and some of these are old AP style problems, or very much like old AP style problems. But again, it's just a review over what we've learned so far. So for this first one, it says the graph of f is shown, and we have g of x is equal to 0 to x of f of t dt minus 2x. So if I were to do my ladder of success, I would have G prime, and G double prime. And then I would have for G, it's the integral of f minus 2x. G prime, well, the derivative of this function would be f of x minus 2, because we got to take the derivative of the minus 2x. And then the derivative of that would be f prime of x. Since we have the graph of f of x, then I need to be looking at the y values when I'm talking about g prime. I need to be looking at the slopes when I'm talking about g double prime, and I'm going to be looking at the area when I talk about g. Now, the other thing that we have is our fun chart. Let me see. Let's write out our fun chart. Hopefully you have this memorized. So remember, on our fun chart, we have f prime, and f double prime. And it's positive, negative, 0, undefined, increasing, decreasing, max, min, concave up, concave down, point of inflection. Okay, so that is our first row for our fun chart. I don't know if I can get that all in. Then we skip 3 boxes and we start again. So positive, negative, 0, undefined, increasing, decreasing, max, min. Then we skip 3 and another 3, and we start again. Positive, negative, 0, undefined. So that is our fun chart that we're going to use to help us answer these questions. Okay, so we want to find g of 5. Well, we're going to take we're going to take 5 and plug it into the equation for g. So it'll be g of 5 is equal to the integral from 0 to 5 of f of t dt minus 2 times 5, because we have that minus 2x. So we're going to do the integral. That means the area. So from 0 to 5, we're going forwards. This would be a quarter circle where the area is 4 pi, so that would be pi. This guy would be 1, 2, 3, 1, 2, 3, so 9, so 4.5 in magnitude. So we would have pi plus 4.5, that's the area piece, and then we would have minus 2 times 5, which is 10. So what does that give us? 5 minus, let's see, 5.5 for g of 5. All right, write the equation of the line tangent to g at x equals 4. So remember, we need our point and our slope. So our point is going to be g of 4, which is going to be the integral from 0 to 4 of f of t dt minus 2 times 4. Okay, so the integral from 0 to 4 now, it's going to be pi, and this piece is only going to be 2 because we're only going to 4. So it would be pi plus 2 minus 8. 2 times 4 is 8. So that would be that g of 4 is equal to pi minus 6. Then we need our slope. So we need g prime of 4. Or remember, g prime is f minus 2. So that would be f of 4 minus 2. To find f of 4, we're going to look at our y values. So at 4, our y value is up here at 2. So that would be 2 minus 2, which would be 0. So when we have a slope of 0, it's just a y equals line. So it's going to be y equals pi minus 6. Okay, then it says find and classify all extrema on the graph of G over the interval from -5 to 5. So we're going to be looking at maxes and mins. So if we look from -5 to 5, we've got, okay, so we want to know where G prime of X, which is equal to, according to our formula up here, F of X minus 2 equals 0. So this is where it gets a little bit tricky, because now what we're looking for is not just the graph of F, it's where the graph of X minus 2 equals 0. So what I'm going to do is I'm going to move that graph around, that 2 around, and I'm going to be looking for the place where F of X equals 2. Well, F of X, if I graph 2, I have this piece right here, that's this line. So where they equal is where they intersect. So let's do the easy ones first. So the first place that happens is at X equals 4. The next place it happens is at X equals 0. And then if I estimate this, since my slope is 3, I'm going over a third every time I go up a value. So I'm going to go 1/3, that would be 2/3, that would be 3/3, and get me all the way to -3. So this would be 2/3 of the way between -2 and -3. So that would be -2 and 2/3, which would be -2, 6, -8/3. Again, you can write the equation of the line and you can find it, but I know that since my slope is 3, I'm going up 3 over 1, then I need to go up a third each time I go over, so that I can get 1/3, 2/3, 3/3, all the way over there. So that's 2/3. So it would be -2 and 2/3, which would be -8/3. Okay, so now we have to classify. Okay, so let's see if we look at this. If F is greater, then the slope is then G prime is going to be positive. So when F of X is greater than 2, G prime of X is positive. When F of X is less than 2, then G prime of X is going to be negative. Okay, and we're doing that solely based on this equation right here. So if F is bigger than 2, then it's going to be positive because F is the positive number. If it's less than 2, then F is going to be negative because -2 is the bigger number. All right, so that's what we're looking for, is how does F compare with 2? So here, F is this guy, so between between -5 and -8/3, F is greater than 2, so we are at a maximum. So I'm going to do me a little sign chart. Let's do my -8/3, 0, and 4. Okay, so to the left of -8/3, F is greater. We said that when F was greater, G prime was positive. So I am going to put a positive symbol in here. Okay, so then between -8/3 and 0, it looks like F is right here. So it's below our 2 line. So when F of X is less than 2, we have G prime is negative. So we're going to put a negative sign. After 0, here we are again. F is below the line Y equals 2. So F is less than 2. So G prime is negative. And then after 4, F moves to be greater than the line Y equals 2. So when F is greater than 2, G is positive. So there's our sign chart. Now this is for G, so that's for increasing, decreasing. So we're increasing, decreasing, decreasing, increasing. So our maxes and mins, we're going to have a max at -8/3, and we're going to have a min at 4, and we're going to have neither at 0 because we don't switch. So then our answer, we're going to have X equals -8/3 is a max because G prime, we're talking about G now, changes from positive to negative, and we have x equals 4 is a min because G prime changes, this time from negative to positive. So it's just a little bit more detail oriented, a little bit trickier when it comes to finding those critical values because you have another piece thrown in with the equation. All right, let's try another one. We've got, okay, so the graph of f is shown. This time h of x is equal to the integral from -3 to x of f of t dt minus x squared. So we're going to build our ladder of success. So I'll build it here and okay, so we have, this time we have h. So we have h, h prime, and h double prime. We know that h is the integral of f minus x squared. We know that h prime, okay, so the derivative of this function is going to be f of x minus 2x, and then h double prime is going to be f prime of x minus 2. All right, since we have the graph of f of x, we're going to be looking at y values when we're talking about h prime, slopes when we do h double prime, and area when we do h. Okay, and then, of course, we've got our good old sign chart. I'll pull that out when we need to. All right, so we want find h of 2. So h of 2, just plugging into my equation, is going to be the integral from -3 to 2 of f of t dt minus 2 squared. So if we go the interval from -3 to 2, let's see, this is going to be 1.5. And then this piece is going to be 2 pi. Okay, so that would be from -3 to 2 would be 1.5 plus 2 pi minus 2 squared, which is 4. So that would be equal to 2 pi minus 2.5. That's a 2.5. All right, then if we want h prime of 2, so h prime of 2, we said was going to be f of x minus 2x. So that would be f of 2 minus 2 times 2. And we said to find f, we want the y value. So the y value at 2 is 0. So it's going to be 0 minus 4, which is -4. H double prime of 2 is going to be f prime minus 2. So h double prime of 2 is going to be f prime of 2 minus 2. So now we're looking at the slope at 2. Well, what do we know about the slope at 2? That's a corner, so it does not exist. So h prime of 2 does not exist. Okay. And then the last thing, we want to determine where h prime is decreasing. Remember, if I pull up my fun chart, where did it go? Here it is. If I pull up my fun chart, when I want my function to be decreasing, I want my derivative to be negative. Okay, so decreasing means my derivative is negative. So I want h prime of x, which happens to be f of x minus 2x. I want to know where that's 0, so I can build a chart. So that's where f of x is equal to 2x. Okay, so if I graph the line y equals 2x on here, 1, 2 here, 1, 2 here, 1, 2 here. So that's that line right there. So I need to know what that intersection point is. Ugh, okay, so that means I've got to write the equation of the circle. Actually, we're going to use our calculator to figure this one out. Okay, because I don't want to do it by hand. So I'm going to graph the semicircle. So remember, a semicircle is the square root, no, clear, square root of radius squared. So that would be 4 minus x squared. And then I'm going to graph the line, clear that out, 2x. Not 20, 2x. Let's graph. Oh, good. Okay, so let's find that intersection point. So second trace 5, enter. And my intersection point is 0.8944. So this happens at x equals 0.8944. Okay, so remember when we're talking about this guy, when f is greater than 2x, our value is positive, our derivative is positive. When f is less than 2x, our derivative is negative because the negative 2x piece is bigger. So we want decreasing, so we want negative, so we want to know where f is smaller than 2x. That means the graph of f needs to be below the graph of the y equals 2x. So that happens on this interval right here. So my interval is going to be from 0.8944 to 5 because h prime of x is negative. Okay? So we just have to compare the two graphs and see which one is bigger, which one is smaller. All right, one more. We have the graph f of x equals g of x minus cosine of x over 2, and the graph of g is shown to the right. So here's the graph of g. Find the integral from -2 to 4x of f of x dx. Okay, so the first thing that we're going to do is just replace f of x with our equation. So that would be the integral from -2 pi to 4 pi of g of x minus cosine of x over 2 dx. Now I'm going to split this apart because we're going to work them separately. With g, we're going to find the area under the curve. With the cosine x over 2, we're going to do the antiderivative. So I'm going to write it as the integral of -2 pi to 4 pi of g of x dx minus the integral of -2 pi to 4 pi of cosine of x over 2 dx. Now, integral of g, we can use area. So that's 2 pi, that's 4 pi. So the base of the triangle is 6 pi. The height of the triangle is 2 pi. So 2 pi times 6 pi is 12 pi squared divided by 2 would be 6 pi squared. Everybody okay with that? My area is going to be 1/2 my base, which is 6 pi, times my height, which is 2 pi. Okay. Then I've got a minus. Now I need the antiderivative. So the antiderivative of cosine, remember, is positive sign, and then we put the reciprocal out front. So this is like a 1/2 x, so the reciprocal of 1/2 makes it a 2, and then we turn it to sine of x over 2, and we're going to evaluate it at 2 pi and 4 pi. Okay, so we have 6 pi squared minus, remember when we do this, top bound goes in first, so it will be 2 times the sine of 2 pi minus 2 times the sine of -pi. Now, the good news is both of these guys are 0. That's 0, that's 0. So my final answer is just going to be 6 pi squared. Okay. All right, identify all critical values on f. So what we want, our critical values, is when f prime of x is equal to 0. So f prime of x is going to be g prime of x. Taking the derivative of that, now we need to take the derivative of negative cosine of x over 2. Since we're taking the derivative, cosine goes to negative sine, and we pull the coefficient out front, not the reciprocal, the exact coefficient. So it'll change to 1/2 plus 1/2 sine of x over 2. Now, g prime is going to be the slope on this graph. So if I turn it sideways and I look at the slope here, we're going up 2 pi over 2 pi, so the slope is 1. If I look at the slope over here, I'm going down 2 pi over 4 pi, so that slope would be 1/2. So I'm going to have to treat this like a piecewise function. So I'm going to have to say from negative 2 pi to 0, we're going to take 1 and set it equal to 1/2 sine of x over 2, and we're going to solve for sine, or we're going to solve for x. So if I multiply by 2, then that gives me 2 is equal to sine of x over 2. But sine, remember, can't go above 1, so that's not going to give me any answers. So now let's try the other piece from 0 to 4 pi. So g prime, we said, was 1/2, is equal to 1/2 sine of x over 2. So if I multiply by 2, I get 1 is equal to sine of x over 2. So sine is 1 at pi over 2 is equal to x over 2. So x is equal to, let's see, if I multiply by 2, that would give me pi. So that is my critical value for my graph. All right, and the last one, we have h of x is equal to the integral from 0 to 3x of g of t dt, and we want to find h prime of negative 3. So to find h prime of negative, well, first let's find h prime of x. So h prime of x, remember we're going to take our function and plug it in. So that would be g of 3x. Then we have to multiply by the derivative of what we plugged in, which is 3. So that would be 3g of 3x. So then h prime of, negative pi over 3 is going to be 3 times g of, if I plug in negative pi over 3, I get negative pi, which would be 3 times, since this is a graph of g, I look at the y values. So at negative pi, my y value is pi, and so that would be 3 times pi, so that would be 3 pi. The marks on the graph are by pi's. All right, so that would be my answer to h prime of negative pi over 3. All right, that is it for today. I know these are a lot harder, so it just takes practice. The more you practice, the better you'll get. If you have any questions, come see us, guys. Bye-bye.